In a concert hall, the 5th row has 19 seats, and the 8th row has 25 seats. How many seats are in the 1st row? We know that the seats do follow an arithmetic pattern, so I want to know what is row 1, 2, 3, 4, 5. I know row 5 is 19, 6, 7, 8 is 25. So I'm jumping 1, 2, 3 places. So in 3 places, I can see the difference is 6. In 3 places, 1, 2, 3, the difference is 6. So 8 minus 5 is 3 places. So I'm going to take the difference in the number of rows divided by the change in rows. So we went from row 5 to row 8, which is a difference of 3. This is how many seats, the difference in the number of seats per row and the difference in the actual rows. When divided, I get an answer of 2. What does that tell me? Well, let's check if this works. 19 plus 2 plus 2 plus 2, it works. So I want to go now back downwards. Subtract 2, subtract 2, subtract 2, subtract 2. So with this particular problem, we can say that in row 1 of this particular concert hall, there would be a total of 11 seats. 11 seats in the 1st row. In this problem, I'm going to review how to write the equations of a piecewise function. So I'm going to start from left to right. So in this problem, I have a line that is decreasing, and it is a diagonal straight line. So I'm going to use y equals mx plus b. So I'm going to come up with the slope first. From left to right, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. Now I need to determine if I extended this, where would it cross the y-axis? Follow the pattern. Down 2, right 1. It would cross at -1. Okay, this is a horizontal line at +3. And again, I have a diagonal. Again, I'm going to follow y equals mx plus b. So what is the slope? Down 1, right 1, down 1, right 1, down 1, right 1. Don't forget the x. And then where does this cross the y-axis? So I can't see it, so I need to extend it the opposite way. It would cross at this value right here, which is 1, 2, 3, 4, 5, 6. So I've come up with the equations. Now I need to be able to show that it only occurs on parts of the graph. So the boundary lines here will be -1 and +1. This particular portion only occurs to the left of -1. It only occurs to the left of -1. So x to the left of -1, it is a solid dot. A line goes underneath. Y equals 3 occurs between -1 and +1. Between -1 and +1. I always go, see how this has a closed dot? Same reason, put a line underneath here. I always think to myself, well, start on the right-hand side. And again, thinking this as an arrow, I want to go to the left. So I'm going to make an arrow that faces towards the left. Okay, we got it. And then I'm going to copy that symbol back in. The reason I'm not going to put a line underneath is because of an open circle means it's not included as part of the function. Lastly, I have this diagonal line. I've already created the equation, but notice it only occurs to the right of the x value 1. So x is greater than 1, no underneath, because we're not going to include that point. Let's solve this for x. Could we work with fractions? We sure could, but sometimes it makes it more difficult. So I want to find a way, and I meant to put underneath here, and I meant to put a 7. I want to find a way to eliminate the fractions to make it easier. So I'm thinking of these 3 groups, and I'm looking specifically at the bottom number, 4, 7, and 1. And I'm thinking, what's the smallest number they all go into? Some of you that are great with multiplication skills can come up with that quickly. Others need to think to themselves, 4, 8, 12, 16, 20, 24, 28, so on. Then I do 7, 14, 21, 28, and then obviously 1, 2, 3 keeps going. 28 is the first number they all go into. So I'm going to multiply both the left and the right side by 28. As long as I multiply both sides by the same amount, they'll keep the equation balanced. How does this make anything easier? So it's going to be distributed to both groups, to the first group and to the second group. So I'm going to first divide, and it's going to make my life easier. I know 28 divided by 4 is 7. 28 divided by 4 is 7. And then I have to multiply it times the top. 28 divided by 4 is 7. 7 times 3 is 21. Okay, 28 divided by 7 is 4. 28 divided by 7 is 4, multiplied times the top. 4 times negative 5 is negative 20. And 28 times 1 is 28. And that was the whole purpose, is try to eliminate, attempting to eliminate any fractions. Now I'm just going to distribute the 21 and the negative 20. Now I'm going to continue here to combine like terms. 21 minus 20, both with x's. 42. Now 42, most of you are going to do this in your head, but 42 minus 20 is going to be a positive 22. And continue to solve, isolating the x. Oh, it's ugly 22. 28, subtract 22, hold it pretty easy there, is 6. So how do you know if I did this right? You're taking a test. How do you know if you did this right? Well, you substitute 6 back in here, and you can do this in decimals instead of doing mental math. And 6 plus 2 is 8. You take 8 times this and 9 times this. You better get an answer of 1. So in this problem, you're told that we have a function h of x, but you're not told what the function looks like. We don't know, we don't know the function's like 2x plus 1. We don't know what it is. The only thing we're told is, hey, we know a few points. We know the point 3, 7. 3, 7 is a part of that. We're also told the point 6, 13 is a part of this function, and we're told the point 10, 21 is part of this function. But we don't know right now. We haven't tried to derive what is a function. And then we're asked, if you know g of x is the inverse of h of x, do you know any of the points? And so we've tried to kind of pound this in here at the Algebra 3-4 level. Remember, the inputs are the x's, the domain. The x's of the original become the y's of the inverse. So 3, 3, 6, 6, 10, 10. And the y's of the original become the x's of the inverse. So yeah, in fact, I do know. If this is the original function and I provided this and we're told, hey, we got another function, we know it's inverse. Do you know any points that would be on the inverse? All I have to do is I have to flip the x and y and I come up with a new pair. If you're asked to solve this equation, and we have to give an exact answer, how can we do that? So remember, you always can factor. In this particular problem, let's see here. So 2 times negative 7 is negative 14. Okay, do I know numbers that somehow multiply to give me a negative 14 and also combine to give you a 20? No, doesn't mean this problem can't be done. It just means factoring doesn't work. So then I have 2 options from factoring doesn't work in order to solve. First is completing a square. So I'm going to move 7 to the opposite side. When it moves over, it's positive. Then I'm going to factor out a 2. And I'm only going to focus on this trinomial on the side. Taking the b value, divide it by 2, include the sign, and square it. But I didn't just add 25 to the right. Remember, I have to keep things equal. So if I add something here, I have to add the same value over here. I didn't add 25, I added 50. So on the left-hand side, I'm going to add 50. And now I can rewrite this by factoring it, and I don't even have to think. I take whatever is here, and I put x in front. Now the goal here is to solve. So the next thing I'm going to do is I'm going to divide both sides by 2. 57 divided by 2 equals x plus 5 quantity squared. And then remember, taking the square root of both sides tells me you're going to have 2 answers, plus or minus the square root of 57 over 2 equals x plus 5. And lastly, to isolate the x, I'm going to subtract. So I'm going to subtract 5 to the opposite side. And these are the two answers. One time adding and one time subtracting. What does it mean to be the answers? It means if we graphed this original function and we're like, hey, where are the x-intercepts? These would be the two x-intercepts. One time when you add, and one time when you subtract. Can we also get that answer using the quadratic formula? Yes. Now you do need to have the quadratic formula memorized. It will not be provided to you. I think most of you were introduced to that probably in the 7th, 8th grade. So in this problem, A is 2, B is 20, and C is negative 7. A is 2, B is 20, and C is negative 7. I'm just going to plug them in as is. So what does this mean? It means, okay, I'm going to change the sign of B. So this is negative 20. And then I'm going to use a calculator to do that work. And then 2 times A would be 4 underneath. So I'm going to come over here. Anytime you plug something in, you need to use parentheses. So B squared, so 20 squared, subtract 4 times A times C. So inside I end up with 456. And you may be thinking, this does not look like this. It doesn't look anything like. And that's because we have to work to reduce this. So that's what I'm going to do. I'm going to start just using perfect squares to see, is it possible? So perfect squares 1, 4, 9, 16, 25, 49, and so on. So I'm just going to try. Let's try dividing by 16. That doesn't work. Divided by 4. Ooh, that does work. Okay. So negative 20 plus or minus. Okay. 4. Oh, I put the wrong number in. Darn it. Let's try this again. 16 does not work. 4. Gosh, darn it. Divided by 4. 4 does work. Okay. So I know 4 times 114 equals 456. Sorry about the confusion there. Okay, and now we'll continue to work ourselves down here. So square root of 4 is 2. Okay, and now this can be shared with both sides. So my number is negative 20 over 4 plus or minus. And then right here we have 2 over 4. I'm just going to keep going here. So negative 5 plus or minus 1/2 times square root of 114. And you may be thinking, like, they look a little bit different. But are they sure these are the same? Well, let's check. Are there different ways to rewrite it? Let's check and see. Let's add and see. Negative 5 plus the square root of 57 divided by 2. Okay, so when I add, this is what I came up with. Now let's try over here and let's try adding. Negative 5 plus 0.5 times the square root of 114. And we can see they're exactly the same. So just two ones to write here. We were able to solve this trinomial, whether you use completing the square method or quadratic formula, both coming up with acceptable answers. When you're asked to identify the end behavior, one option is to plug it into the graphing calculator or into Desmos and see what does it look like. The other option, much quicker, is if you've memorized this, remember, this represents even, this represents odd. Positives are on top and negatives are down below. What am I talking about? So I'm looking for the degree. The degree is an odd number, so I'm only going to look at these options. Now, if you happen to miss this day, this probably sounds like I'm talking gibberish, but the degree is 3. 3 is an odd number, so only one of these two options. And the leading coefficient, the number in front, is positive. So this is positive and odd. What does this tell me? Again, you're welcome to plug this into Desmos or onto a graphing calculator and you get the same thing. This is just a quicker way for those that have memorized this. This says as I go to the right, the function will be going up. As I go to the left, the function will be going down. In this problem, I'm given a polynomial equation, and I'm asked to determine which of the following is a factor. Only one of these is a factor, and so I'm going to test them one by one until it comes up. We're going to learn about synthetic division, and in the previous video I said, hey, don't worry about that. Synthetic division is an easy way, sometimes I call it the mama method, to do this. We're doing long division, that's why I went over in class. This will also work. So what do I do? Well, I write it down. Put down I have 1x plus, and I want to know if it's a factor, I get the remainder of 0. Okay, 1 times what is 1? I need 2 more x's. And then I multiply through. Changing the signs always on the second row, and then I combine down. Doing the concept again, 1 times what is 3? I need 2 x's, which means I need 1 more. So I end up with 3x squared minus 3x, changing your signs and adding down. 1x times what is negative 2x? Negative 2. Multiply, change the signs, and add down. What does this tell me? If the remainder is anything other than 0, it tells you this is not a factor to this equation. What does that mean? It means that x equals 1 is not an x-intercept for this equation. Let's try it for the next one. So I can write it a little bit smaller. X minus 2. Just one of these is a factor. Okay, here we go. 1x squared. I'm multiplying it through right now. Changing signs. 1x times what is 4x squared? So plus 4x. Multiplying through. Changing signs. 1x times what is 3x plus 3. Multiplying. Changing signs, and there I get a 0. So yes, I have found the factor. I have found the factor. So if this is a factor, again, I get a remainder of 0. What does it also tell me? It tells me that the x-intercept is x equals 2. If we're provided this problem and we're asked to determine the type of root, so we're talking about imaginary and real. Sometimes they call them complex instead of imaginary. So I'm going to write down real and complex. Well, how many should there be? Well, in this function, there should be a total of 3. So it says using technology. I would start by graphing this in Desmos or using a graphing calculator, and the first thing I'm looking for is how many x-intercepts we have. Well, let's just say we have 3. Making this up. Well, then 3 and 0, because these two numbers have to add up to the degree. What if we only had 1, which is not the case for this particular equation, but if we only had 1 x-intercept, that means there'd be 1 real, and the remaining number to help these two add up to 3 would be 2. So it would be 1 real and 2 complex if we had another equation in which after graphing it you only see 1 x-intercept. Okay? And what do they have to add up to? The degree, the highest. In this problem we're asked to rewrite this function in factored form. So in order to do factored form, we want to know what are the x-intercepts. So I would start by going ahead and I would graph this in Desmos. Now, once I graph it in Desmos, I can see, oh, there's an x-intercept at -1, there's an x-intercept at +2, and there's an x-intercept at -3. Those are the 3 real roots. So what do I do once I know the x-intercepts? Then I rewrite this with 3 factors. Remember, it's going to lie to us x plus 1, x minus 2, and x plus 3. To make sure, you could always graph this in Desmos and graph this in Desmos. You'll see that they're the exact same.